Exercise 10.02 are statistical calculations which identify a place within a set of data. So when the data is arranged smallest to biggest, and that's really important, then we could separate our data into quartiles, or we could separate our data into deciles, or we could separate our data into percentiles. Now, quartiles comes from the word a quarter, so we take our entire set of data and we divide it into four equal quarters, and we identify the cut-off points after 1 quarter, 2 quarters or the middle, 3 quarters, etc. Deciles is where we measure where we take our entire data set and we divide it evenly into blocks of 10. So we've got we divide it into 10 equal blocks. And then percentiles is when we take our complete data set and we divide it into 100 equal blocks. So it says here, quartiles break the data set into quarters. Q1, or the lower quartile, is the cutoff for the lowest quarter of the data. Q2, or the median or the middle, indicates halfway, and Q3, or the upper quartile, is the third quarter cutoff. It says find the quartiles for each data set. Now, the problem with this is it's not in order smallest to biggest. I'll just pause the video and get it into order. So you can see there are 10 marks obtained by the students, and halfway would be after 1, 2, 3, 4, 5. So our median, or Q2, would sit here. Now if we divide this into quarters, then this is my Q1 and this is my Q3, or upper quartile. So the quartiles are Q1 would be 41, Q2, or halfway, is in between 46 and 51, so we add those two together and halve them. So what's that? 97 on 2, which is 48.5, and Q3 is at 60. We're going to find the quartiles in this set of data, and again I need to arrange it in order small. Now in this example, you see that we have a total of 9 scores. Now this provides us with an interesting situation. It's very easy to identify the second quartile, or the middle. It's this score exactly of 5. And the rule is then we ignore that 5. We don't include that 5 in the calculation for our lower quartile. So our lower quartile is the middle of only these 4 scores. So the middle would occur here between 3 and 4. So Q1 is actually 3.5. Q2 is the 5. And Q3, again, we ignore the 5. We only consider the top 4 scores, and we want in between 6 and 6, which is 6. The next example shows deciles nicely marked off. So there are 20 results, or 20 babies were measured, and deciles means we're going to mark the position after every second baby, length, smallest to biggest. Says, what is the third decile for this data? The third decile is here. It's between 48 and 49, so it's 48.5. What's the fifth decile? It's between 50 and 50, which is 50. What's another name for the fifth decile? It would actually be, there's a couple of names you could call it. It's right in the middle, so it's the median, or we could call it Q2, or we could call it halfway. Find the value that separates the bottom 70% of lengths from the top 30. So we're sitting here. Here's the top 1, 2, the top 30, and the value that separates them is 51.5. I think these are centimetres. If the length of newborn baby James is in the top 10%, what value must it be greater than? Must be greater than 54 centimetres, because 54 is our D9, halfway between 53 and 55. This next example is a nice combination of these measures of positions. It's introducing now percentiles or hundredths. So you can imagine dividing your data into 100 equal divisions, and each one would be called a percentile, 1%, 2%, etc. And P1 cuts off the lowest hundredth, the very first hundredth, and which actually represents 1% of the scores, up to 99, which would represent 99% of the scores. Now, I was saying this question is an interesting combination because it starts off telling us about the data for the heights of girls aged 16. And it talks about the median. So the median is the middle. It then talks about the third quartile, back to quartiles. Now we know the third quartile is the equivalent of 3/4 of the way through, which in terms of percentile is 75%. 75% of the girls' heights are up to 167 centimetres. The 9th decile, now talking deciles, so lots of tens, and so we'd be talking 90%, measure up to 171. The 5th percentile, 5%, the bottom 5% are only 152 centimetres, but the 97th percentile, that's all but the very top 3%, are up to 175 centimetres. So like I said, it's quite a mixture of these measures that tell us about the position of a result within the entire data set. Says in the following question, all the girls mentioned are age 16, so they are going to fit into these descriptions. Holly's height is 175. 175? Looks like we're here. Is she tall for her age? If she's in the 97th percentile, then she's very tall. She is taller than 97% of the people. So we'd say, yes, Holly is tall as she is taller than 97% of 16-year-olds. And what percentage of 16-year-old girls are taller than her? Only 3% of girls are taller than Holly. B. Olga is taller than 90% of girls her age. What is her height? So 90% is the equivalent of the 9th decile. So at 9th decile, we're here. 9th decile, 90%. What is her height? She would be 171 centimetres. C. If a quarter of the girls her age are taller than Verity, a quarter of the girls are taller than her, how tall is she? So only a quarter are taller. So she must be 3/4 of the way through the heights. 3/4 is the equivalent of Q3. So we're referring now to this measurement. So she must be 167 centimetres. Because Q3, we take the entire group, we break it into quarters, first quarter, second quarter, 3/4. And we know that's called Q3, or upper quartile. D. What height separates the bottom 5% of heights from the top 95? So the bottom 5%, here we've got 90, the bottom 5%, the 5th percentile, so that's 152 centimetres. And finally, what percentile of height is a height of 163? What percentile? So where's 163? The median is 163. The median is the middle. What is the middle percentile? The middle of 100% would be 50. The 50th percentile. Okay, so I think that would be enough now for you to make some summary and do 1002.